This is actually assignment 7.4. I don't know why it says 6.3. If that really bugs you, cross out 6.3 and write 7.4. I didn't want to copy the paper again, waste paper. So this is assignment 7.4. Okay, I'm going to go over examples A, B, and C. Honestly, we're probably just going to do example A, and then you'll see a little video for B and C next time that you look at this. And then it's due on Tuesday. So kind of the customary things that you'll work on it on Monday. You'll work on it on Monday, so it'll be all right. You should have the matrix assignment done by then anyway. All right, now I chose examples A, B, and C to just kind of give you guys a flavor for some more application. This is kind of more the customary application, you know, how many apples and how many oranges are in the basket type thing, except we're kind of spicing them up a little bit. We're not just going to do those basic apple and orange problems, but it's more of some customary application. Letter A is kind of a specific example of a quadratic application. So again, I don't expect that you already know this, but I think once we go over some of these, you kind of start thinking again like these applications. There's actually a little fact here about a parabolic equation. A parabolic equation is basically a quadratic equation. And you would have seen this in an algebra context. We actually will continue to visit it more this year. But any quadratic equation will always fit the form ax squared plus bx plus c. And all that's really saying is that you're going to have an x squared, and you could have other numbers around it. And you should all say, yeah, when you have an x squared, it's a parabola. But there could be other numbers that are part of the equation. So we just kind of call that standard form for any quadratic equation. Now, what is this? What is this all about? Well, there are points. There are points that are on a parabola. And normally the way the story goes, if teacher gives you points, you should be able to come up with the equation. Except this is a quadratic equation. It's a parabola, so it's a little more fancy. But the cool thing is that these points are just x and y, like they always have been. And so we're going to do something that's not going to totally knock your socks off. We're just going to plug these numbers in for x and y. But watch carefully as you plug 9 in for y. Take a look at where that goes. And then look at what happens when you plug 1 in for x. Now, I'm showing a couple other pieces here so you can see the whole layout. Because all I did was I plugged a 1 in for x and a 9 in for y. But I didn't plug anything in for A, B, and C. Okay, as you guys are going to find out, that's what we're trying to find. That's what we're trying to solve for. Are you tracking? We're plugging in for x and y. Something that you would have done in many algebra situations. It's just that now we're plugging into this ax squared plus bx plus c. And the story continues. And of course, something is being created here. Something is being created. And of course, I'm talking about the big picture. I plugged in, whoops. What am I doing? I plugged 6 in for y, and I should have plugged 4 in for x. My bad. So we got to plug a 4 in for x. That looks better. It would be a good idea for you to think about the last point, 614. Are you following the little pattern here? Just plug. Now be careful. Make sure you plug in 14 for y. Make sure you plug 14 in for y. And again, something is being created. Now, if you don't quite see the creation yet, let's simplify this. Basically, let's kind of organize it so it looks a little bit more normal. It looks a little bit more kind of the way you like to see it. First of all, if I do some math in this first equation, I'm just going to end up with a plus b plus c. all those ones are going to allow me to end up with just A, B, and C. We can see a little bit more math in the second equation. I hope you see 4 squared equaling 16. I'm going to write that as 16A. I'm going to write as 4B. And again, are you starting to see what's being created here? It looks like we're creating something with coefficients and constants. 36A, 6B, and C equals 14. Again, it looks like we're creating something with coefficients and constants, something we know to be a system. Okay, now make sure you realize that what's really going to happen here is we're going to solve for A, B, and C. That's a big takeaway. And I don't know about you, but it looks like it's all primed and prepped for our new technique. Now I'm doing something here that I'm also giving you guys kind of liberty to do. If you say, yeah, Ms. Naylor, that's fine. I can see that that's matrix A and that's matrix B. We don't need to rewrite things 10 times. So we already showed some work. We already got it organized. And again, if you're comfortable with what I did there, I'm fine if you do that. So the implication is to solve for A, B, and C. You can do it if you want. You can just kind of watch, but make sure you're thinking about what's going on here. We're solving for A, B, and C. We're typing in matrix A and B. If you're feeling good about what's going on here, that's good. I hope you are. But I'm kind of curious, do you understand what the answers mean? Yes, we want to get the answers, but do you understand what these 3 integers mean? Call it 1, -6, and 14. Because again, as we get into more application, I want to see you guys interpret your solutions. So we get 1, -6, and 14. One simple interpretation would be that A equals 1, B equals -6, C equals 14. Okay, so that definitely is one level of understanding, that you realize that those are A, B, and C. But if you kind of read the question again, or if you think about the big idea in this problem, we were trying to come up with an equation. So yeah, your final answer is actually taking these coefficients, A, B, and C, and writing them into an equation. Of course, an equation of the form ax squared, so 1x squared, plus bx, so minus 6x, plus 14. Now for just a little more math. You guys look like you could use still a little more excitement here. For a little more math. Do you realize what we really have done? Okay, we really have come up with an equation for a parabola. You know, like a graph of a parabola. And that's like a zoom standard. There's nothing wrong with it. Everything's kind of like up in the top quadrant there. I'm just going to play around with the window so I can get a better view of what's going on here, all I did was I just kind of got rid of some of the wasted space. It's just messing around with the window. If you didn't see what I did there, I started more at -2. I also made the y value. I made the y value get quite a bit bigger. But here's why. Here's why. Look, this parabola actually has the points that we called for. It actually has the point 1, 4. Yay, good. I mean, that's the way it was supposed to work. It actually has the point 4, 6. Now, just by the way, what I'm doing here, if you want to do it, is I'm pushing the trace button, but then I'm typing the x value. So I typed the x value of 4. And basically, I land right on my target. But this is what's supposed to happen. So I'll trace to x equals 6. What I really did was I typed in x equals 6, and I see my last point. Now this begs the question, do 3 points always make a parabola? We all know that 2 points always make a line, and that's good stuff, but I wonder if 3 points always make a parabola. That'll probably be there'll be a little activity that we'll end up doing together, whether we're in person or remotely. We'll continue that question briefly at some point. Okay. Now, examples B and C, I will still go over those. Okay. Again, probably virtually, but then you'll basically be able to work on this assignment sometime, Monday, Tuesday. As you can see, it'll still be due Tuesday.